Welcome to the 9.2 video about double and half angle formulas. So a couple new formulas for you are the double angle formulas. Again, they'll be given to you on a half sheet or on Schoology, so please don't worry about memorizing them. They are going to be given to you. Now, these aren't brand new, so they all can be derived from what we already know. For example, if I want to derive sine of 2 theta, that would be the same thing as sine theta plus theta. So really, it's the addition formula for sine. Well, I know that addition formula is sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle, which as you can tell, they are the same thing. So that just means I have two of them. So 2 sine thetas, cosine theta. Okay, so that is derived. That's where it comes from. Again, don't worry about memorizing. Just know how to use them as we move forward. So for example, let's use the double angle formula here. Now it's telling us that sine is 4/5 and we are in quadrant 2 because it's between pi halves and pi. So as always, I'm going to draw my picture. I know sine is 4/5, so this is 4, that's 5. When you do Pythagorean's theorem, you'll see this actually becomes -3. Notice you're going to the left, so that's why it's negative, and you use Pythagorean's theorem to find it. Now it wants you to find a couple quantities. So the first one is cosine of theta. Well, that one's easy because I found that last side of my triangle. So cosine of theta is just -3/5. All done there. Next one it wants is sine 2 theta. Well, now I know what sine of 2 theta is using my double angle formula from above. So that is 2 sine theta cosine theta. So I simply plug in. I know sine of theta is 4/5. I know cosine is -3/5. So when you multiply that out, you should get -24/25. So just use your formula, plug in, and you're good to go. The last one is cosine of 2 theta. That formula is cosine squared theta minus sine squared theta. I know cosine theta is -3/5, squaring that, and sine squared is 4/5, and you have that squared. Move up a tad. So when you're solving this, I get this is positive 9/25 minus 16/25. So the double angle formula for cosine is actually -7/25. So it's really helpful to draw that picture. Make sure you know what quadrant you're in to know if your x or y value is positive or negative. And then you find your cosine and your sine from there. Okay, here's another type of an example. So here we are given that x equals 4 sine theta. You are in the first quadrant, 0 to 2 pi. And we want to express sine of 2 theta in terms of x. Now, we have seen stuff like this before, and people get a little nervous because their answer has an x in it. That is completely okay. You're going to do all the normal math, but you just sadly don't know one of the side lengths. So as always, I'm going to draw myself a picture. I am in the first quadrant here, 0 to 2 pi. I know x equals 4 sine theta. That's kind of hard for me to read. So what I'm going to do is just get sine theta by itself. That means divide both sides by 4. So So sine theta equals x over 4. That I can understand. That's like the last example we had. You know your angle. Sine is x over 4. So then I can start drawing my picture. Now we need to find our third side length, like always. So we'll do some Pythagorean's theorem. X squared plus, we can call this length, I guess, b if you want, equals 4 squared. So we're solving for b squared. So you get 16 minus x squared. So this side length right there is actually square root of 16 minus x squared. Very, very weird. Again, it has a square root and an x squared, so people get nervous, but all you need to know is that is your side length. Notice it's positive because it's going in the positive x direction. Okay, so let's finish up solving this. In the solution, I gave you kind of a hint if you were a little stuck, but it said given the equation is equivalent to sine theta equals x over 4, exactly what I have there in red. So now we're finding sine of 2 theta. Using my formula, I know it's 2 sine theta cosine theta. My sine is x over 4. Cosine, it's a bit messy, but there is my work. That actually won't be good. In the end of my final answer, I'll do a little bit. So this would be 2x square root of 16 minus x squared all over 16. Make sure you multiply your denominators. Final answer, then you can divide that 2 out. Nothing can get out of this square root because it's that group. So this would be your final answer. The picture is extremely helpful, so hopefully you take advantage of that. Okay, a couple new formulas. We now have the half angle formulas. This is helpful, and I have example 3 to kind of bring it out for us. It's helpful when you have a degree like 105, so example number 3, cosine of 105, using the half angle. Well, you can use the fact of cosine of 210 divided in half. I picked cosine of 210 because I really know some information about this. I know that the reference angle, give me a sec, I'll write that out a little bit more. I know that the reference angle for 210 is 30 degrees. I know it's in quadrant 3. So I actually know a lot about cosine of 210. That's why I'm using that and the half angle. If it doesn't specify how to solve it, so in this case it says half angle, you don't have to use it. You could use the addition formula if you want. You could do cosine of 60 plus 45, but this one just specifically says half angle. Now you use the formula as given, and you pretty much solve it. Looking at the algebra, don't stress out a ton about the algebra. I care about the setup. The one thing that needs to be understood is it positive or is it negative? Well, you're looking at this degree, 105. 105 is in quadrant 2. In quadrant 2, is cosine positive or negative? Well, cosine in quadrant 2 is definitely negative. So that's why in the end, our answer will be negative. So all of these symbols right here, sorry about that, all these symbols would be negative. So we're leaving as plus or minus that whole time to show you that it could be positive, it could be negative. And you need to realize at the end, look at your angle and see what quadrant the terminal side falls on. and figure out if it's positive or negative. Okay, so a lot of algebra, you can get common denominators like we do here. And I'll show you an example on the next page about the rest of the work. But this is your half angle formula. Make sure you find a nice angle to use. So, example 4, we'll get into what it really looks like. As always, I'm going to draw my picture. This is between 270 and 360, so that's quadrant 4. I know sine is -1 over 10. When you do your Pythagorean's theorem, I can show you that. The Pythagorean's theorem would be x squared plus -1 squared equals 10 squared. So x squared would equal 99. Oops. Take the square root. X would equal plus or minus 3 root 11 if you simplify that square root. Now notice I'm in quadrant 4, so I'm going to use the positive x. I'm going to the right. So this is really 3 root 11. Using our formula, we want to find sine of theta over 2. Go back and put, this is theta. So the formula, plus or minus square root 1 minus cosine theta over 2. Remember, if it's sine of theta divided by 2, it's 1 minus cosine. Well, let's start filling in our picture here. So I know that the cosine of this angle is 3 root 11 over 10 all over 2. Doing some algebra, this is going to be 10 minus 3 root 11 over 10 all over 2. I just got that common denominator, which in the end, we can just leave it as 10 minus 3 root 11 over 20. The only thing left now is, what sign is it? Is it positive or is it negative? We need to look at the restriction. So 270 was the lower bound of your angle, and 360 was the top bound. That's for theta. I now want it for theta divided by 2. So I'm going to divide each part by 2 to see the restriction for theta over 2. Well, that gives me 135 and 180. So this is the restriction for the half angle. Well, notice that would be in quadrant 2. Quadrant 2, sine, because that's our trig function, is positive, right? All students take calc. So what I'm going to do is go back through. I'm going to erase all, I'll erase them all. I'm going to put it back in the first one though, just so you guys remember it's part of it. But then in the end, it's positive. For that reason, that sine is positive in the second quadrant. Okay, please take a moment, pause the video. You try cosine of theta divided by 2. Okay, hopefully you paused that video. I'm going to go through and just show you in case you have any mistakes or if you have any errors on your answer. So cosine of theta divided by 2 has a very similar formula, but it's 1 plus cosine of theta divided by 2. Again, I'm going to leave the plus minus till the very end. I'm now adding the cosine, which is 3 root 11 over 10. All that's over 2. I'm going to jump a couple steps. Hopefully we can figure out that this would be 10 plus 3 root 11 over 20. If you need help, please look at the previous example. It kind of breaks down that algebra. And now I need to worry, is it positive or is it negative? Well, same restriction as before. This is the restriction on your theta. So I want the half angle, which you could have just looked at the one from above. Same work. This is the new restriction. That's in quadrant 2. And cosine, again, because I'm doing the cosine function, is negative. So I'm going to go through. I'm going to put my negative sign in front. And this is the double angle, sorry, not double, half angle of cosine for this problem. If you have any questions, feel free to bring them to class. Again, don't stress about the algebra as much as just getting the formula plugged in. Good luck!